Hello class, today we are going to review mean absolute deviation, and here it says find the mean absolute deviation of the following sets of data. It says you and your friends measured the height of your dogs. The heights at the shoulders are shown in the table below. Find the mean absolute deviation of the height of the dogs. Now, as we discussed in class, another word for mean is the average. Okay, so just like we say your average in this class is such and such, okay, the word mean means the same thing. Okay, so mean and average are the same. All right, and so what we're going to do to find mean absolute deviation, step one, is to find the mean of our data. So here is my data. I've got, looks like 5 pieces of data. So I've got 5 different dogs. It says the height of dogs in millimeters. So I'm going to take this data and I'm going to add them all together. So I have 600 plus 470 plus 170 plus 430 plus 300. Okay, and then I'm going to hit enter, and I get 1,970. Now I'm going to take that 1,970 and I'm going to divide it by how many terms are in my data, or by how many numbers are in my data. And so I have 1, 2, 3, 4, 5 terms in my data. So I'm going to divide this number by 5. And so I get 394. So right here it says the mean is 394 millimeters. Okay? And so I found the average. Now I have to find the distances of the data from the average. So I'm going to clear my calculator. Okay, and for my first distance, okay, I've got to see how far apart 600 and 394 are. Okay? Now, we had a discussion in class where distance cannot be negative. I'm going to write that at the top of my paper. Okay, distance, so you could say distance is always positive. Okay, but distance, we could say, is never negative. For example, if I was in a plane and I flew up 5,000 feet, okay, that would be positive 5,000 feet. But then if I flew down 5,000 feet, well, I'm still going 5,000 feet. I'm just going down, so that wouldn't be negative. Same idea, right? If you were scuba diving, you could go down. You could scuba dive at a depth of 50 feet, but you're not going negative 50 feet. You're still going 50 feet. You're just going down. Kind of the same idea with walking backwards. Okay? You're not walking negative feet, you're just walking backwards, so you're still going a certain distance. Okay, so distance is never negative, it's always positive. So I'm going to look at this first distance here. So I'm going to go from 600 to 394, and I'm going to see the distance there is 206. So I'm going to write all of my distances just right beneath here. So I've got 206 as my first distance, right? And you could even write right here, distance from the mean. Okay, and so my first distance is 206. My second distance, I would do 407 minus 394. I can see that distance, I'm sorry, it's 470. 470 minus 394, that gives me 76. My third distance would be 170 minus 394. And notice how I get a negative number, but remember we said distance can never be negative, so the distance between these two numbers is 224. Okay, and I have 430 minus 394, and that gives me a distance of 36. And finally, I have a distance of 300 minus 394. And remember we said distance is always positive, so the distance between these two numbers is 94 units. Okay, so now I found all my distances. Now I must find the average or the mean of my distances. So just like I found the mean of these numbers, okay, now I'm going to find the mean of these numbers, and this will give us our mean absolute deviation. So I'm going to do 206 plus 76 plus 224 plus 36 plus 94, and that gives me 636. I'm going to divide that now by 5 because I have 5 distances. And that is 127.2 is my mean absolute deviation. Now let's see if it wants us to round. It doesn't say anything, so I would just write 127.2 millimeters is my mean absolute deviation. Let's take a look at number 2 here. A bus route takes about 45 minutes. The company goal is a mean absolute deviation of less than half a minute, or 0.5 of a minute, or another way we could say that is 30 seconds. One driver's times for 9 runs of the route are shown below. Did the bus driver meet the goal? So the goal is for the mean absolute deviation, right? So the goal is for the MAD to be less than or equal to 30 seconds. Okay, and how we know that is, it tells us this is 9 runs, this is 9 different times for bus routes, okay, and the times are in minutes. Okay, but this series says half a minute, so we want the deviation of all of these times to be half a minute. We don't want the actual bus route time to be half a minute, because these are the times. See, we take, on one bus route, we take 44.2 minutes. Here we take 44.9 minutes. We just want the deviation between them to be 30 seconds. Right? And that makes sense, because if you're taking the same bus route every day, right, then it should take you, theoretically, the same amount of time. Now, of course, there's real-life variables like traffic, right, or car accidents, or, you know, different things that can happen that skew that deviation. But in a perfect world, right, we would want that deviation to be 0, because if you're driving the same bus route every day, it should theoretically take you the same amount of time to get from point A to point B. Okay? But we're going to calculate the mean absolute deviation. So first we must calculate the mean. So I'm going to take all these numbers, 44.2, and I'm going to add them together, plus 44.9, plus 46.1, plus 45.8, plus 44.7, plus 45.2, plus 45.1, plus 45.3, plus 44.6. It's a lot of numbers. And I get 405.9. Okay, and now I'm going to take that 405.9 and I'm going to divide it by how many numbers I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to divide by 9. And I get 45.1. So the mean, okay, or the average amount of time it takes for the driver to drive the bus route is 45.1 minutes. Okay, and now I've got to find the distances. So once again, I have the distance from the mean.
Joseph Cachero, please come to the front desk. Excuse this interruption. We need Joseph Cachero to the front desk as soon as possible.
Well, I guess Joseph better get up there. All right, so now we have 45.1, and we're going to find the distance here. So I'm going to take 45.1, and I'm going to subtract 44.2. And I get 0.9 is my distance for the first one. Same thing here with the next one, 45.1 minus 44.9. So I get 0.2. 45.1 minus 46.1. So the distance is going to be positive 1, because remember, distance cannot be negative. Okay. Then I have 45.1 minus 45.8. That's going to be positive 0.7, because remember, distance, once again, cannot be negative. 45.1 minus 44.7 is going to be 0.4. 45.1 minus 45.2 is going to be positive 0.1. And then we have 45.1 here, so that distance is 0. Okay. And then we have 45.1 minus 45.3. That gives me negative 0.2, which would be positive 0.2, because once again, distance cannot be negative. And our last one is going to be 0.5. Okay, so I've done all these distances in my calculator, And now I've got to take the mean of the distances, and that will give me my mean absolute deviation. So I'm going to clear this out. I'm going to do 0.9 plus 0.2 plus 1 plus 0.7 plus 0.4 plus 0.1 plus 0 plus 0.2 plus 0.5. So I just took all these numbers here, all the distances, and I just typed them in and added them together, and that gave me 4 exactly. So I'm going to take 4 and I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to take 4 divided by 9, and that gives me 0.4444 repeating. Okay. Now, for the mean absolute deviation, the way I would write this is 0.44 repeating. This little sign here, this little line over these numbers means that these numbers repeat continuously. Okay. And remember, the goal, okay, was for the MAD to be less than or equal to 30 seconds or less than or equal to 0.5 minutes. And so we have to decide, is 0.44 repeating less than 0.5? It definitely is. So the bus driver did meet the company goal, because the company goal, remember, was to have a a mean absolute deviation of 0.5 or less than 0.5, and we definitely accomplished that with 0.44 repeating. Moving on to number 3. Jason and Jill are 2 students in Miss Davis's math class. Their grades on the last 10 assignments are shown in the table below. Okay, so this is a great real life example of how I, as your teacher, use mean absolute deviation in real life. Okay, so we've got Jason's scores and we've got Jill's scores. Okay, and it says who has a higher average grade. So first we need to find the average of both of these students. So we can take the average of Jason's scores, which would be 76, plus 81, plus 85, plus 80, plus 87, plus 85, plus 94, plus 80, plus 90, plus 72. So I get 830, and I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so Jason's average is an 83, right? So I might want to write that somewhere to the side. Maybe I could say Jason's average right here is an 83. Okay, and now I'm going to do Jill's. So Jill was 79 plus 90 plus 92 plus 83 plus 73 plus 84 plus 100. Look at that, got 100. Plus 82 plus 74 plus 83, which is going to be 840. So I'm going to divide that by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so Jill's average is an 84, or Jill's mean score is an 84. Okay, and so who has the higher average? Well, obviously Jill does, because her average is an 84, and Jason's average is an 83. So Jill has the higher average. Who has more consistent grades, and how do you know? So to figure out who has more consistent grades, we must find the mean absolute deviation. Okay, because the smaller our deviation is, the more consistent the grades are. The bigger our deviation is, that means the more our grades are spread out, okay, or the more they are deviated, the more they are separated, if you will, or not close to each other, okay? And that's really what mean absolute deviation tells us. It tells us how the data is either really close together or how it is kind of far apart, right? And if you just kind of look at the data, you can see, I'm gonna bet that Jason's scores are a little bit, more consistent than Jill's, because if you look at Jason's, they seem to be a little bit closer together, right? You got a lot of B's, you got maybe one A, you got a couple of C's here, maybe a D, but Jill's scores are kind of all over the place, right? You've got C's, you got A's, you got B's, you got 100, you got you know, it looks to me like these numbers are a little bit more spread out, but the only way to be for sure is to find the mean absolute deviation. So we're going to do distance from the mean on both Jason's and Jill's scores. Okay, so I'm going to start with Jason's average. So I'm going to do 83 minus 76. So this distance here is 7. I'm going to do 83 minus 81. That distance is 2. 83 to 85. That distance is 2. 83 to 80. That distance is 3. 83 to 87. That distance is 4. 83 to 85. That distance is 2. 83 to 94, that distance is 11. 83 to 80, that distance is 3. This distance is 7. And this distance is also 11. Okay, so I've got all my distances, and now I'm going to find the average of them. Okay, so I've got 7 plus 2 plus 2 plus 3 plus 4 plus 2 plus 11 plus 3 plus 7 plus 11. That gives me 52, and then I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So Jason's mean absolute deviation, or MAD, is going to be 5.2, and I'm just going to leave that right there like that. Okay, because now I have to calculate Jill's. Okay, so Jill's average was 84, so the distance between 84 and 79 is 5. The distance between 84 and 90 is 6. 84 and 92 is 8. 84 and 83 is 1. 84 and 73 is 11. 84 and 84 is 0. 84 and 100 is 16. 84 and 82 is 2. 84 and 74 is 10. And 84 and 83 is 1. And so now I'm going to add these numbers together. 5 plus 6 plus 8 plus 1 plus 11 plus 0 plus 16 plus 2 plus 10 plus 1. Okay, and I get 60, and I'm going to divide that by 10 because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And so Jill's mean absolute deviation is exactly 6. Okay, and so to answer this question, it says, who has more consistent grades? Well, that answer would be Jason. And we know that because Jason has a smaller mean absolute deviation, or MAD, okay, which tells us his data is closer together. Okay, and so while Jill has a couple grades that are better, like this 100, right, as Trey Daniels would say, perfect, right? Jason has a smaller MAD, okay, and so that tells us that his grades are more consistent. And so what would it mean if a student had a MAD of 0? Well, if a student had a MAD of 0, that would mean that all of their scores are the same. So this would mean that all of the students' scores are the same. And how we know this is if all of these scores were the same, well, there would be no deviation between them because they're all the same. There would be no distance between them like we find here for Jason and for Jill. These are all the distances from their average. Well, if you had, for example, let's say they made an 84 10 times, right? So if they made an 84 10 times, I would do 84 plus 84. I could do this 10 times, or I could type 84 times 10. Okay, that'd be 840, and then I would divide it by 10 scores. And so that score that they got every time would be their average, right? And there would be 0 distance between this average and the scores because they're all the same, meaning their mean absolute deviation would be different, which means that the student would always score the same on their test. Now, obviously, that rarely happens. It happens on occasion, right? For example, I think in one of these, let's see, did Jason or Jill score the same? Yep, so see, Jason scored an 80 twice, right? So it happens every now and again, okay, where a student will score the same on a test, but to score the same on every test, that's extremely unlikely. Okay, so a MAT of 0 generally never happens, but it is possible if you do somehow manage to score the same on every test. Okay, and this is how we do mean absolute deviation. It will be on your STAR test. This is a great review for you to review for your STAR test, and this is your homework that is due on Monday. So hopefully you're able to watch this video, and hopefully it helps you. And this is Mr. E signing out.